Welcome to CCT 5.0 Sideloop Descriptions video. Literature location for CCT is in the product literature internal site on the portal as well as Quicklette. There you will find the help in PDF file format, which is the same as online help. The objectives of this video is to understand the operation of the new analog to binary control side loop application, as well as to understand the impact of selecting the Create State Selection side loop options. So let's look at this new side loop feature in Release 5.0. I have CCT open. There is no program loaded. What I'm going to do is create a new application, and this is going to be a custom application. And the reason I'm choosing custom is so that I don't have any other influences on the screen layout, so I can just focus on the side loop application. So I have my custom application open, and as you can see, there is nothing here, nor is the Select System button available to me. Everything that gets created in a custom application is manually created. And this works out well for demonstrating just this one side loop application. So I'm going to click the side loop button, and we're going to see what's new at Release 5.0. I'm going to first collapse the feedback control and identify that the feedback control side loop has been unchanged at 5.0. The binary interlock control also has not been changed. And this first checkbox we had before as well, the Create State Selection to Interlock the Side Loop option. What's new at Release 5.0 is the analog to binary control, and this side loop is what we're going to be studying in this video. We're also going to see the impact of creating a new input for interlock. That option we'll also select and see the impact of that as well. So now let's take a look at these side loops. We already know that the feedback control side loop is for a side loop where an analog input is used to control an analog output or staged outputs. The binary interlock control interlock is when you have a binary input that controls a binary output or a two-position analog output point. The new interlock, analog to binary, will take an analog input, and if it's greater than or less than a set point, then a binary output is controlled. So let's see how this works. I'm going to click on the analog to binary control and expand it. And then I'm also going to put this red rectangle around it to identify the main contents of this side loop. For example, the first one is the analog type. Your input point then would either be temperature, humidity, or other, which is identified as pressure. The second option you have is to identify how many inputs would you like. Just one? Or would you like two inputs? And then you have an option of selecting the minimum, the maximum, or the average. The control action for reverse acting or direct acting is also available to control your binary output point. So what I'm going to do is I'm going to identify a specification here which this side loop will match. For example, let's create a side loop here that when occupied is set and the zone temperature is greater than a set point, I want to turn on an exhaust fan. When I'm not in occupied, then the exhaust fan will remain off. So I do have a temperature input, so therefore I'll keep this selection for temperature. I only need one input, so I'll leave that there. Control action is going to an exhaust fan, so I'll make that direct acting, because I know that if the analog input zone temperature goes above a set point, I want the fan to turn on. And now for the other option down here, creating a new network input. I mentioned that I want this to be controlled by an occupied point, which is going to be in my network input area of CCT. So I'll leave this as a new point, as a network input point. And what this is going to do is create a network input point as well as a state generator module to control the contents of the state table. I'll click Finish. I can give the side loop a name. I'll call it T1 and hit the OK button. So my selections have been applied and the control view is visible. So let's see what was created by this side loop. First of all, we have our input point, and that's the side loop temperature. SLT is its name. Here's going to be my side loop set point. And here's the side loop interlock state network input point. This is the point that's actually going to be an input to this new state generator module, which is actually going to be used then to control the output control module to determine what state to go in. And then this output control module will then control through its logic the binary output point. I also have parameters set here. Here's the differential value that will be used in our logic. And here's the actual side loop output state, which is the output of our output control module. So let's look at some of these connections here. We'll take a look at this one here first. This is the side loop interlock state network input point. Looking at its connections, we do see that it does go to the input of the T1 side loop pass-through. So if I go to the state generator called the T1, which is the name of my side loop, this is the side loop pass-through state generator block. When I look at its connections, we can see then that the input does indeed come from this network input, and the output of the state generator goes to the state table. So let's look at the state table. And here we have the pass-through state generator. Its default is off and on. So depending on your application, you may need to change some enumeration sets so everything connects up properly. And we also see that an off of the state generator produces an off in our binary control module. And a on in the side loop state generator is also going to produce an on in our binary output control module. Now here's where I want to define something in much more detail. When I look at the options here, I do notice that I only have off and on as an option. I don't have control for the output control module. The on here means that the logic in the side loop will actually control the binary output. The off here indicates that the BO will actually be off. So if you are going to choose on right here, that means the logic inside the side loop output control module will control the binary output. So let's take a look at that. First of all, we'll look at the connections to our binary control output control module, which is the side loop. And we can see that the mode input comes from the state selection table. The process variable is our temperature sensor, and the set point is our set point that's found in our network inputs. And the output goes to the binary output. Let's study the logic. So here's the logic of our analog to binary side loop. And here's our mode connector. And it's coming into this block here. If you notice at release 5, the block names are fully exposed. So I'm going to just raise this up just to make it a little bit easier in analyzing this. So we can see now that the mode connector is coming into the mode of this mux block. The input to that mode connector is either going to be off or on. If I double click on this mux block, I can find out what port will actually be selected, whether it's input 1 or input 2. And here I can see that an off will select input 2 and pass that value through. Well, if you notice, there's nothing connected to input 2. So whatever value the default is here, it'll pass through and go to the binary output point. Well, input 2 has a default of off. Therefore, the binary output is send a off command when the mode right here coming from the state table is off. When you have an on command, and I'll switch to a green color here, if you're going to send a on command from the state table, then input 1 is selected. Well, input 1 has a connector, and you can see where it's coming from. It's coming from the logic in this logic layer. So therefore, whatever the logic is, as far as our analog input being greater than or less than the set point, the binary output is either going to be commanded on or off. So if you have an on coming in here, if this is going to be an on state, then the logic controls the binary output. If you're going to be in a off state, then off is commanded to the BO. So that's how this logic works. Going back to the control view, these are all the points that were created by using the option of create new input for interlock. That's where this network input came from, as well as this state generator module. So that's how this new side loop application works. I'm going to go back to the PowerPoint slide and look at one more. And here we have our objectives for this video was to understand the operation of the new analog to binary control side loop application. And that side loop compares an analog input to a set point. And if the result of that comparison is beyond a differential, then a BO is commanded. Also, we wanted to understand the impact of selecting the Create State Selection side loop options. These two options creates a state table entry for controlling the side loop's output control logic, as well as specifying an input point and a pass-through state generator module for selecting the state in the state table.